Hey everyone. I want to point out that all of the TAs have office hours now. The office hours appear on the screen before you, but you can also find this list by going to the class webpage and clicking on the link entitled Getting Help. And so we have office hours every weekday of the week. And I want to introduce the TAs to you and encourage you to go see any TA that you like, and not just necessarily your TA, but all of the TAs are ready to help you during their hours. So this is Leonard. This is Michael. This is Kenrick. And this is Srini. So please take advantage of these gentlemen as much as you can to learn what you need to for this class, and any other way you can. That's it. Thanks very much for showing up. All right, pipe down. Today is another lecture on arrays and loops. So I want to start off by telling you about automatic array construction for two-dimensional or higher dimensional arrays. In the last lecture, we used a loop to construct a multidimensional array. And the reason we did that is because we wanted an array that was shaped like a triangle. But for the vast majority of things that you will do, where you need a multidimensional array, you will probably be happy with a rectangular multidimensional array. And if you do that, you can get Java to create all of the arrays for you at once, instead of having a little loop that creates the arrays in the array of arrays one by one. And here's the syntax by which you do that. You, as usual, declare an array of arrays. But when you create the new array, you specify both numbers, meaning both dimensions of the array at the same time. And ta-da, Java will create for you as usual an array of references to arrays. But in addition, Java will also create for you X separate arrays all at once, each containing Y ints. So it'll look something like this. You've got your reference, Java creates your array, and Java creates as many subarrays of ints as you need. And the only difference between what we did here and what we did with Pascal's triangle is now we specify a number here. And so it saves you a lot of effort when you want a rectangular array. We could have used a square array to store Pascal's triangle if we'd wanted to, and that would have wasted some memory because not all of the entries of that array would have been used. But if you have a small Pascal's triangle and a big computer memory, you probably don't care. Another way to create arrays of arrays inadvertently is by using initializers. And so an initializer is any case where you declare a variable and assign something to it at the same time. And Java will let you do some special kinds of assignments in initializers that you can't necessarily do in plain old assignment statements. So for instance, I can declare an array of humans, and while I'm doing it, I can actually specify what that array of humans is going to be, and Java will create an array for me. So I assume I already have some references to humans, or maybe I'm making them up as I go along by using a constructor. But when I do this, Java creates an array of 3 humans for me and fills in the 3 references as well. I can also do this for multidimensional arrays. So I can say two-dimensional array of ints, call it C, and do something fancy like that. And you'll notice that this is another way to create an array that is not rectangular if you want to. Because in this example, there's an array of 4 arrays. And the first array has 3 ints, and the second has 1 int, and the third has 4 ints, and the fourth has 2 ints. So that's another thing you can do. But sadly, you can only do that with initializers. I wish you could, but you cannot do something like this. Just an assignment statement where you do an automatic array constructor and just assign it when you're not initializing. Or better yet, even be able to say, call a function and just pass in a brand new array to it that you construct on the spot. These are things I wish you could do in Java, but you need to know that you can't. This kind of notation is only allowed in initializers. So, no good. Try to do this, you get a compile time error. Any questions about this? Yeah. Uh-huh. Oh, well, I'm calling the constructor that constructs a brand new human. This is using one of the constructors that I gave in a previous lecture. And when this constructor gets called, it's actually going to create a new human object, and it's going to return a reference to that object. And then when we create this array of 3 humans, that reference will actually get written into the third entry of that array. Yeah, Kayla and Rishi were already references to humans that we have from previous code from several lectures ago. Other questions? Yes. Uh-huh. The question is, when does this evaluate these variables? And basically, whenever this line of code gets executed, this initializer, that's when X and Y and Z get evaluated. And that's also when the arrays get created. All right. One more syntactical thing you should know about arrays in Java is that there's several different ways to declare them, and this is especially important to know when you're reading other people's code, is that if you do something like this, I think this is the clearest way of writing a declaration. It's first you specify the type. The type is going to be an array of ints, and then you can specify the variables that you want to be of that type. So in this case, all 3 of these variables, A, B, and C, all reference arrays. On the other hand, you don't have to specify the array marker as part of the type. Instead, you can specify it as part of the variable. And so I can write a declaration like this. And so what this means is that A is a one-dimensional array of ints. B is just an int. It's not an array at all. And C is a two-dimensional array of ints. And in fact, this is the C style of declarations. In C, this is the only way you're allowed to do this. Finally, you can mix the two, just if you want to be extra confusing. I don't encourage this, but if you ever see something like this, what that means is that A is a one-dimensional array and B is a two-dimensional array. You basically add up the number of arrays on the variable with the number on the type. Any questions about that? All right. So Java can magically create an array of arrays for you. So it's important that I warn you that it won't necessarily do the same thing for an array of objects. You can declare an array of objects, you can create an array of objects, but Java will not automatically create the objects for you. So you have to write a loop that walks through the array and constructs the new objects one by one. And just to be totally clear, I'm going to show you the code for that. So this code, incidentally, it should be on your handout, along with a bunch of other code snippets that we'll be looking at shortly. And so this is just a simple example of, here's the trick. To see this, we need to turn the light off, so now you can't see your handout. Oh well. So here's the code we care about, though, and we are creating a new array of 5 fractions, and so what that does is it just creates the array of 5 fraction references. And it's up to you, if you want actual fraction objects, to write a loop that goes through and creates all those fraction objects one by one. So here's another interesting array that comes up in Java, is you may have all noticed that there is a parameter to the main method that every program starts with, and that parameter is an array of strings. So our new subject is mains parameter. So we've declared this args of type array of strings. What is that? What it is it's a list of command line arguments that you typed at the Unix prompt. So what this loop, which is also in your notes, does is it walks through the loop, and remember the way to know, or it walks through the array of strings. And remember, the way to know how long an array is by looking at args.length. And for each one of the strings in that array, it prints it out on the screen so you can take a look at it. And so, for instance, if you were to type at the Unix prompt, first of all, that you want to run the program echo in Java, the echo class, then everything you type after that is command line arguments, and Unix takes them apart wherever there are spaces between them into separate strings. And so you get 4 separate strings here: kneel, and, worship, Java. Any questions about that? So the next thing I want to do is I want to look at loops in a little more depth. One useful part of Java is something called a do loop. So a do loop is a lot like a while loop, but the do loop always executes the loop body at least once. As compared to a while statement, which might not execute the loop body at all. And so, here's an example of a short program where this makes sense. The idea here is we want to read a line from the keyboard, a line of text, you type it in. Then we want to process that line of text somehow. Maybe it's your next bank transaction. And we want to exit the loop if the string is an empty string with length 0. But the first time we get to the loop, the very first time we hit the do statement, S is not defined yet because we haven't read anything from the keyboard yet. We have to read something from the keyboard at least once before it makes sense to check this condition at all. So a while loop doesn't really make sense here. A do loop makes a lot more sense. So we use a do loop. It guarantees that this gets executed at least once and reads something from the keyboard before deciding whether to quit. But the way to look at this particular loop is that it's doing two things over and over again. It's reading from the keyboard, and it's processing whatever it reads. And there is a natural entry point to the loop, which is before we read something for the first time. And because it is convenient to have a loop exit from the same point in the cycle where you enter, this loop winds up exiting here. So we do read, process, read, process. But you might say, well, if we read the string and the string is empty, there's nothing in it, then maybe it doesn't make sense to call process at all. So maybe that's the wrong place to exit the loop. So you will probably find frequently that you have to write loops where the natural entry point into the cycle here and the natural exit point are not the same. And so there are several techniques for how you can do that when that comes up. So one thing that's really helpful there is something called the break statement. And you've already seen the break statement used in switch clauses, but we're going to see other uses of break now. And break has a cousin called continue, so I'll teach them both right now. So what does the break statement do? The break statement always exits the innermost switch statement or loop that the break is inside. Now, to see how we can use that, remember our little loop that does a read and a process and keeps doing that over and over again. Well, the natural entry point for that loop is we want to read first because we can't process anything until we have something to read. But the natural exit point is that if we read the user saying, I want to stop, then that's where we want to exit. So we've got a loop. We want to enter and exit from different points in the cycle. And so that makes it very unclear where we should start the text for the loop and where we should end it. Well, one solution is to use a break statement to exit out of the middle of the loop body instead of waiting for the end. And when you want to do this, this comes up so commonly that it has a common name. It's often called a time and a half loop. Called time and a half because you want to iterate this loop a certain number of times plus a half. Could I move the paper up? Oh yeah, that's right. So here's an example of how you write one of these. This is, again, in your handout. Well, this is one example. I'm going to show you two different ways to do this. This is the way that does not use a break statement. And the idea here is you duplicate some of the code. You do a read line before you start the loop. Then, if the line is not empty, then you go ahead and you process whatever you read, and then you read again, and then you decide whether to repeat the loop again. So that's one way you can do it. The other way is you can do the break statement. And so that's the example on the bottom here. Here the idea is we're only going to have the line that reads from the keyboard once. And we're going to have it inside the loop. We're also going to have the process statement inside the loop. But we can exit the loop from the middle of the loop instead of exiting from the bottom of the loop. And that's why we use a break statement. One curious thing you'll notice about this loop is that the condition is just true. This is a loop that's designed to basically loop forever unless a break statement occurs. Question? Mm-hmm. I would say, well, there's a number of considerations. So I'm actually going to write a list of disadvantages from a code style point of view. Though you had mentioned efficiency, which wasn't something I was going to mention, but since you asked, I will mention it. So let me go through the full list of disadvantages of each of these. So the top one, I think the main disadvantage is the repeated code. So we've got this duplicated code that appears twice. S equals keyboard.readline, S equals keyboard.readline. Why is that bad? Well, in this case where we only have one line of code that we're duplicating, it's not that bad. But in a lot of situations where you have these time and a half loops, that might be 100 lines of code that you have to duplicate. And if you have to duplicate 100 lines of code, you're doing something wrong because that can cause all sorts of problems. The main one being that if there's a bug in that code, you might come back and forget that there's two copies of it and only fix the bug in one of the two places. Or, more likely, if you're working for a company, one of your coworkers will have to come fix a bug in your code, not know that there's two copies of it, and only fix one of the bugs. That's one thing that can go wrong. Another... What's my other problem? Oh yeah, the other problem is just in terms of maintainability. If one of your coworkers needs to fix your code, which is what a lot of time in the software industry is spent doing, is fixing other people's code, then they actually have to go through the first 100 lines and the second 100 lines and compare them and make sure they really are the same code and that you didn't do something slightly different in one of the two. So repeated code should be avoided whenever possible. And the longer it is, the more it should be avoided. And that's what gives the second loop its advantage. What is maybe the disadvantage of the second loop is it's a little bit more obfuscated. It's harder to read and just look at it and see exactly what it does right away. You have to think harder and longer about it because the loop isn't aligned with its natural endpoint. Now, the question you asked about was efficiency, and I'm thinking about this, and I'm honestly not sure which of these would run faster. I'm leaning towards the one on top being slightly faster because you've got this extra if statement here. On the other hand, the top loop has the while statement, which is essentially also doing a conditional. Conditionals tend to be expensive on processors. And so it's really hard to know what the trade-off would be. The other thing is that when you duplicate code, sometimes that makes the optimizer not work as well, especially in really good optimizing C compilers. And I know this is Java, but the C code looks identical, actually. So, are there other questions about this? Yeah. Okay, yeah. So the question is, to avoid the repeated code, could you just take this, whatever code is here and whatever code is duplicated here, and stick them all into one method and just call that method twice? And the answer is sometimes yes, that's a great way to handle it. I mean, that's sort of the standard way of dealing with duplicated code, is to put it all in one subroutine. The case where that might not work out is if the duplicated code manipulates a lot of local variables in this procedure. When you take code and move it to another method, that code can no longer change the local variables in this method. And that's what makes this process of using subroutines to get rid of duplicated code painful sometimes. Is that if there's too many local variables being modified, it's just too hard to do. All right. So what I just showed you was an example where, as I said before, you've got a loop whose natural endpoint is different from its natural entry point. Well, some loops have more than one natural endpoint. Like, for instance, suppose we want to make one change to our read process loop. We want to make sure that it only ever iterates 10 times, and then it stops. So you only get 10 requests, and then you're done. Well, in that case, there's a natural exit point here when the user says, I'm done, I don't want to do any more transactions. But there's also a natural endpoint after the 10th transaction where you just process the 10th transaction. You know you're not going to do an 11th, so you don't bother to read something you're not going to process. So now you've got a loop where you actually want to exit the loop in two different places. There's no way you can align the code in the loop so that both exit points are aligned with the end of the loop body. So this is a place where it's just very natural to do something like this. This is also in your handout, where there are two endpoints for the loop. One is, this is a loop that only runs 10 times, so we exit here after the 10th iteration. Or if the user enters an empty string, then we exit here too. So there's two different places in the loop body where we can exit the loop. Now, there are some people who are, seriously anti-break Nazis. They don't think you should use the break statement anytime ever. But you might ask yourself, how would you rewrite this loop so that you don't use break statements at all? Well, it can be done. There's sort of standard transformation techniques for doing it. But this is what the code looks like if you do that. So now you'll notice that the conditional has grown complicated to include both of the exit conditions. And you'll notice that no matter how you judge it, this code is just less readable, harder to understand than the top example. And so I don't agree with the anti-break Nazis. I think that there are times when break just makes your code more readable, more clear, more maintainable. And in this example, I would say that there are no advantages of the bottom one over the top one. I'd go for the top one every time. Any questions about that? Yeah. What's so bad about break? Well, so it's sort of like what's bad about goto, which is, well, I don't know how many of you are familiar with goto statements from other languages, but they make the flow of control less clear. When you have a loop that's always aligned with its natural endpoint, you don't have any doubt about what the flow of control is. You can just almost look at the indentation of the code, and without actually looking at the code, you can figure out the flow of control. But with a break statement, that kind of breaks your assumptions about what the control flow is and makes code, some people argue, a little harder to read. I think this is a counter-argument to that. Hello, yeah. Yeah, you can have as many breaks inside a loop as you want. That's right. So you could have a loop, a really long loop body with 10 natural exit points, and that happens. Yes? Well, runtime errors are sometimes a natural exit point, too. So that would be another example of a natural. What would be an unnatural? Just any, if you have a sequence of lines of code, sometimes you always want this line to be executed after this line. I mean, if I had a larger, most loops that you look at, there's only one natural exit point, which is the bottom of the loop. So, you know, pick an example from your favorite program, and it's probably an example like that. I don't think I'm saying this very well. Maybe we should talk about this after class, because. Okay. Sorry. Any other questions? Yes. Well, I mean, it is possible to use a for loop, yes, but that would be really confusing. That's kind of not what the for loop is meant for. The for loop is meant for when you're looping through something a clear number of times. And although you could use it here, it would be really unreadable, and I don't recommend it. I think it's bad style. So one warning I want to give you about break statements is that sometimes it's really easy to forget exactly where a break statement will jump to after it's executed. Like, for instance, break does not jump to the end of the innermost enclosing if statement. So, you know, if you have multiply nested loops, you have to remember where it's going to jump to. If you have an if statement like this, you have to remember that break is not going to jump to the end of the if statement. It's going to look for a switch statement or a loop. So this is not how it works. And an AT&T programmer introduced a bug into a phone switching network by making this mistake, thinking that break worked in this way. And as a result, on January 15, 1990, AT&T's entire U.S. long-distance service went down for 11 hours from that one bug. So now that code was actually written in C, not Java, but Java and C have exactly the same syntax for doing these break statements. So one of the things that they introduced into Java to make it less likely that you would make this mistake is labeled break statements and labeled continue statements where you actually specify where you want to jump to. And so that's the really long code segment you've got here on your handout. I'll come in a little bit and just look at the top. All right, so here's the idea. You can attach labels before all kinds of different kinds of statements. For instance, here's an if statement, which is a labeled if statement. It's got this label test right in front of the word if. And the way you write a label in Java is you just come up with a name for your label and then you put a colon after it. That simple. The colon tells Java this is a label. Likewise, this while loop. You can put labels in front of while loops, if statements, switch statements. You can even just do an open brace and then a close brace later on, enclosing a bunch of statements, and you can make that a labeled set of code. So this stuff label refers to this brace here, which terminates here. The idea is that these labels will hopefully prevent you from making the mistake that AT&T programmer made. And the way it works is you, instead of just saying break, you can say something like break stuff, and that will specifically specify which particular place you want to break to, how many nested loops and switches and if statements you want to break out of. And this gives you more power, more control. You can break out of 2 loops at once instead of just 1 loop. So how does this work? If you just say break, then this particular break is just going to break out of the switch statement. And so you will wind up here, and the next thing you will do is execute statement 1. But if you say break stuff, well, stuff is a label associated with this whole code segment that starts with this brace and ends with this brace. So when you say break stuff, that's going to break out of that whole labeled code segment, and the next thing it executes is statement 2. If you say break loop, loop labels the while statement. So this breaks right out of the while loop, and you wind up at statement 4. And if you say break test, it breaks out of that outer if statement. And you jump to statement 5, and you save AT&T. So we also have something called the continue statement here. And I'll come back to this, but the continue statement is akin to the break statement, but with a difference. First of all, it only applies to loops. It just doesn't make sense in the context of if or switch statements. And second of all, it doesn't actually enter the loop, exit the loop. What it does is it jumps to the end of the loop body, just like a break statement, except you're still inside the loop. And so it does the conditional test again, and if the conditional is still true, it will go back to the top and begin another iteration of the loop body. Question? Mm-hmm. When you do a when you do a continue inside a for loop, it will basically jump to the end of the loop body. It will execute the third part of the for statement again, like the increment or whatever you've got there that advances the counter. And then then it will do the loop test again. You are correct. And I'm not going to repeat that question because I'm going to show you that question in a minute. Oh, yeah. Okay, so I want to go back to the example, the long example we were looking at, which is on your handout again. And so we have these 2 continue statements. Now, here's a just plain old continue. Continue does not apply to switch statements, so this continue has nothing to do with the switch. Instead, it has to do with this while loop. So what it's going to do is it's going to jump to the end of the while loop, but it'll still be inside the while loop. So basically, it's like it jumps here to location 3. And it, let me move location 3 up there. It jumps to location 3. It even skips this I++. And again, you can use labels with continues. Since there's only one loop here, I just say continue loop, which jumps to exactly the same place. But if you had nested loops, like one loop inside another, you could use that to jump to the end of the outer loop body instead of the inner loop body. Any questions about that? Yes? Yes. It just skips everything in that part of the loop, in the rest of the loop body, goes to the bottom, checks the condition again. If the condition is still true, we go back to the top of the loop body. If the condition is not still true, then we go out of the loop altogether. Yeah? Can you say that louder, please? Break can apply to switch, yes, yes. And continue never applies to switch. So the question the gentleman in the front row asked a few minutes ago is a very interesting subtlety of continue that you probably should know about, just in case it comes up. Here's two different pieces of code that, again, this is in your handout. I told you in the probably third lecture or so that you can always take a certain kind of for loop and rewrite it as a while loop, and they'll both act exactly the same. This is one exception to that rule. So I've taken this standard-looking for loop, and I've rewritten it as a while loop. And I followed all the rules. They both look exactly the same, but they are not the same. And the difference is a subtle one. In the while loop, if you hit this continue statement, and that happens, then the continue jumps to the end of the inside of the loop. So you can see it's skipping over this I++ statement. We are not doing I++ here. But that's not how it works in a for loop. In the for loop, this continue statement here jumps to the end of the loop body. We're still inside the loop. But in a for loop, the I++ gets executed every iteration, regardless of whether you call continue or not. So that's the one case where my rule for rewriting a for loop as a while loop doesn't give you exactly the same result. Yes? What happens to the while loop? Well, it doesn't crash, but in this particular case, if condition I is true, it will run forever. So, well, if condition I is true, and even when, for one of those i's, then continue will jump here. I will not have changed. So execution will go back to the top of the loop body, and we'll do it all over again. So the code won't crash, but it will run forever and do nothing interesting. Any more questions about this? Yeah. Break breaks out of a switch, but it does not break out of an if statement unless it's a labeled if and you use the label. Sorry, I can't hear that. This works with both switches and loops. Yes, yes. Breaks works with both switches and loops. Continue works only with loops. I still have one more thing I want to cover quickly, so give me... two more minutes. Another thing you need to know about is called constants. In Java, the way you define a constant is with the final keyword. And what that means is that you're declaring a value that can never be changed. You assign the value with an initializer, but once you've initialized it, it can never be changed again. And so, as a general rule to start following in the future for most purposes, it's kind of bad. It's considered bad form, even though the compiler is happy with it, to do something like this, where you say if month equals 2, where 2 is some arbitrary number that happens to refer to February. And the reason this is considered bad form is you might decide all of a sudden, after writing hundreds of thousands of lines of code, that actually February should be 1 and the months should be numbered from 0. Then you have to go back and find every line of code that refers to February, there might be hundreds of them, and change them all. So to avoid that possibility, what you do instead is somewhere near the top of the class, you just define a final static constant, and you give it a name that's meaningful, hopefully to other people reading your code in the future, and you use an initializer to initialize it to some value. And then, everywhere else in your code, this is much later. So this is at the top of your class. This is inside some method way further down. The right thing to do is say if month equals February, then do something. And the reason why this is the right way to do things is if you ever decide that February needs to be 1 instead of 2, you only have to change your code in one place instead of hundreds of different places. Final note, for any array x, x.length is considered to be a final field, and that's why you can't change it. If you ever try to assign something to a final field other than in the initializer, you get a compile time error. See you all on Wednesday.